Alright, welcome to 6B Notes. So let's look at what we're going to be dealing with in Unit 6 is we're going to be dealing with radicals and also what we call rational exponents. So here are two equivalent statements. This letter N refers to your index. It's the root you're taking. So that N is called an index. Alright, of course this is your radical. And the number underneath the radical is called a radicand. So some vocab. Now this expression, this is a rational exponent. Because we've rewritten this index as 1 over n. So these are equivalent statements, and we're going to be going back and forth between these two. Now you read this as the nth root of a. You're very familiar with square roots when n is 2, but now we're going to be looking at numbers other than 2. N has to be greater than or equal to 2. There's not such a thing as a first root. Alright, so first of all, let's just practice using the vocab, and then we'll get actually into some computations and like fun stuff. Alright, so it says change the radical to a rational exponent. So that means we want it to look like this. We're going to write this with a fractional exponent. So when we take a root, it's the same thing as writing it as a fractional exponent. Alright, so this is the square root of 2. So n is implied to be 2. You never see the 2 written. So as a rational, we're going to write this as 3 to the 1/2. Alright, number 2, n is 3. This is a cube root. So we're going to write this as 2 to the 1/3. Now look at number 3. N is 5. That's our index. But we also have an exponent. So exponents are in the numerator, indexes are in the denominator. So we rewrite this as x to the 2/5. Okay, so maybe we should write those notes down. Exponents, numerator, your index will be in the denominator. Okay? Alright, let's go the other way. So this time we want to change the rational exponent to a radical. Now remember what Stock is telling us. Remember that the denominator is the index. So this was going to be the 4th root of 2. Alright, number 5. The denominator is 5, x to the 3rd. And right now we're just going to rewrite this. We'll simplify something like this later, but this is going to be the cube root of 27 squared. Probably a good idea to put parentheses around that, because if that 27 is negative, that's going to affect our answer. Alright, so that's the other way. So changing from rational to radical, and then from radical to rational. Because we're going to be able to, we need to be able to change both back and forth on these to be able to simplify what we're going to be working with later. Okay, alright, look at this couple of theorems here. So this is saying if we have a to the m over n, we're going to simplify expressions. So we can take the nth root of a and then raise it to the m power. So to get our number smaller and then raise it to the power. Alright, if you have a negative exponent, that means to take the reciprocal. But here again, we can take the nth root of a and then raise it to the m power. Now because a is in the denominator, a cannot be 0, because we can't have 0 in the denominator. So let's apply this. How is this, what are we going to do with this? So we want to evaluate without a calculator 36 to the 3/2 power. So what we can do is rewrite this as the square root of 36 and then raise it to the 3rd power. So the square root of 36 is 6, and 6 to the 3rd power is 216. Alright, number 8. Be careful with negative exponents. That means this is going to be 1 over 16 to the 1/4. And then we can go 1 over the 4th root of 16. Alright, now we're doing principal root. This is not in an equation, so I do not need a plus or minus. The 4th root of 16 is 2. Alright, number 9. we're going to go, we want the cube root of negative 64, and then we're going to square it. So the cube root of negative 64 is negative 4. Negative 4 squared is positive 16. All right, one more. Negative exponent again, so we're going to rewrite this as 1 over 64 to the 1/2, which is 1 over the square root of 64, which is 1/8. When you're simplifying these, you never want to leave a negative exponent. That's part of our simplifying process. Okay, now we're going to solve some equations. All right, next 6C notes, we'll start using these properties more. Okay, so let's solve some equations with radicals and rational exponents. All right, so now remember, when we solve something, we've got to be careful. We've got to remember, when do we need a plus or minus? So if your index or your power is even, we're going to need a plus or minus. Okay? All right, so first thing we're going to do is isolate. So I'm going to divide both sides by 4. So we're going to get x to the 5th is equal to 32. All right, we're going to take the same power to both sides. So you got a couple choices here. You can think about, we're taking the 5th root of 32. I'm having trouble writing those 3's today for some reason. Or you can think about this as 32 to the 1/5 power. All right, those are both equivalent expressions. You can use either one interchangeably. Now, because this is a 5th root, I don't need a plus or minus. So the 5th root of 32 is 2. Now make sure you check your answers, okay? Because sometimes you're going to end up with stuff that doesn't work, extraneous solutions. So let's check our answers. 2 to the 5th power is 32. 32 times 4 is 128. So my answer is good. So please make sure you check your answers when you're doing these. All right, look at example number 2. All right, we have to isolate first. So I'm going to multiply both sides by 1/2, or by 2. I'm going to multiply both sides by 2. So that's going to give me 16. All right, now I need to take the 4th root of both sides. So x minus 3 is equal to, because it's a 4th root, 4 is even, I need plus or minus the 4th root of 16. Anytime you have an even root, you're going to need a plus or minus. You're going to have two answers that work. All right, so let's break this apart. So x minus 3 is equal to plus or minus 2. So x minus 3 equals negative 2, and x minus 3 equals positive 2. So x is equal to 1, and x is equal to 5. All right, let's check both of them. All right, putting in 1. 1 minus 3 is negative 2. To the 4th power is positive 16. Half of 16 is 8. So 1 works. Let's try 5. 5 minus 3 is 2. 2 to the 4th power is 16. Half of 16 is 8. So that one works. So just like I said, be careful when you need a plus or minus. All right, moving on. All right, solving radical equations, equations with radicals in them. So step number 1, you need to isolate the radical on one side. Then your step number 2, raise each side of the equation to the same power to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. And then step number 3, we're going to solve whatever polynomial we get. And we're going to remember to check our answers. So we probably should have step 4 in there. Check your answers. All right, so step number 1, we're going to isolate. So we're going to start moving things away from that radical. So we're going to add 1 first and get 4, and then divide by 2. Can't raise it to a power until you've got this thing isolated. Now raise it to the same power. Because this is a cube root, I'm going to raise it to the 3rd power. So I'm going to x minus 3 is equal to 2 to the 3rd power. So we're going to get x minus, now we're up to step 3, we're going to solve. And you're going to x minus 3 is equal to 8, add 3, so x is equal to 11. All right, let's add our 4th step, and let's do our check step. Go back to the original. So the cube root 11 minus 3 is 8, minus 1 equals 3. Cube root of 8 is 2, 4 minus 1 is 3, and so it checks. So our answer is 11. You will end up with some stuff that doesn't work, so please make sure you check your answers. I know we haven't yet, but I promise you, sometimes we're going to end up with stuff that doesn't work. Extraneous solutions. All right, let's try another one. All right, step number 1, we're going to isolate. So we're going to subtract 2 first. We get 32. Then we're going to divide by 2. Good old equations from Algebra 1. And we're going to get 16. All right, now comes our power step. Because this is a rational exponent, we're going to raise each side to the reciprocal. So 3 over 2, 3 over 2. And because this denominator is even, don't forget your plus or minus. So you're going to have to, like I said, be really careful about getting your plus or minuses. All right, so this is going to give us 1. So this leaves us with 3x plus 4. And we're going to get here plus or minus. We want the square root of 16 to the third power. So we're up to our solve step. Okay? All right, so what do we get? So 3x plus 4 is equal to plus or minus. The square root of 16 is 4, and 4 to the third power is 64. So we're going to end up with 2 answers here. So let's break this apart. You're going to have 3x plus 4 equals negative 64, and 3x plus 4 equals positive 64. All right, do our math. 3x equals negative 68. X is equal to negative 68 thirds. Doesn't divide, so we're going to leave it there like a fraction. And then we end up what? 3x is equal to 60. X is equal to 20. All right, so our 2 solutions. So let's check our answers back in the original. All right, what is this going to give us? Let's try to do, let's see. We've got, that's going to give us negative 68 plus 4 to the 2 thirds plus 2 equals 34. This is going to give us negative 64. The third cube root of negative 64 is negative 4. Negative 4 squared is 16. 16 times 2 is 32 plus 2 equals 34. This one's good. All right, let's check 20. All right, so what do we got? 20. So 3 times 20 is 60 plus 4, 64 to the 2 thirds plus 2 equals 34. Well, that's the cube root of 64 is 4. 4 squared is 16. 2 times 16 is 32 plus 2 equals 34. So my 2 answers are what? Negative 68 thirds and positive 20. They both work. Okay, moving on. All right, how about this one? Let's see. We're going to isolate first. So we're going to subtract 2. So x minus 1 to the 3 halves equals negative 8. All right, we're all isolated. Let's raise to a power. So we're going to do a reciprocal. So that's times 2 thirds. We're going to, whoops, put that in the right, that parenthesis in the right place. 2 thirds. This is odd, so I don't need a plus or minus. So I get x minus 1 is equal to, let's see, I've got the cube root of negative 8 squared. So x minus 1 equals negative 2 squared, which is 4. So x is equal to 5. All right, let's check that answer. So let's put in 5. So we're going to check step. So 5 minus 1 is 4 to the 3 halves plus 2 equals negative 6. Well, that's the square root of 4 is 2. 2 to the third is 8 plus 2 equals negative 6. Well, 10 does not equal to negative 6. So that's not working. That's extraneous. So my answer is no solution. So here you go. Here's your first one where you get something that doesn't work. All right. So watch out for extraneous solutions. Okay. So let's look at the next one. All right, first thing I want to do is I'm going to separate these. If you separate these, this becomes a really easy question. So we want the fourth root of 3x plus 6 is equal to the fourth root of 4x minus 11. we're going to raise both sides to the 4th power. So what that's going to do is going to get rid of that 4th root. So this leaves us 3x plus 6 is equal to 4x minus 11. Now we just solve for x. So we're going to get what? Negative x is equal to negative 17. So x is equal to 17. Here again, make sure you check these. Check it in the original. Okay? So when you put it back in, you'll see that it works. So that solution is 17. Alright, let's look at one more. Alright, look this one. Be careful with this one. Alright, we got our radical already isolated, but we have to square. So we're going to square both sides. So we're going to get 4 minus x squared is equal to x minus 4 squared. This is going to have to be FOILed. This is going to give us 4 minus x is equal to x squared minus 8x plus 16. This is a quadratic, so we're going to get two solutions. So we need to move everything, get it in standard form. So I'm going to move everything to the right. So it's going to be add 4 and add x. So negative 7x, subtract 4. Let's see, subtract 4, it's going to be plus 12. And that's equal to 0. This we're going to have to factor. So what multiplies to give you 12, but adds to give you negative 7. So negative 3, negative 4. So x minus 3, x minus 4 equal to 0. 0 product property, set each factor equal to 0. So x equals 3, x equals 4. Now make sure you check these. Alright, a dead giveaway. If you have variables on both sides with these radicals, you may have an extraneous solution. Let's put 3 back in. 4 minus 3 is 1. The square root of 1 is 1. But 3 minus 4 is negative 1. So that doesn't equal. So 3 is not going to work. How about 4? 4 minus 4 is 0. Square root of 0 is 0. And then 4 minus 4. Okay, so that one works. So my only answer here is 4. So like I said, be careful. You will end up with extraneous solutions in some of these cases. So get in the habit of checking these always. Alright, if you have any questions, please let me know and I'll see you in class.